Hi everyone, a very good evening to all of you. I hope I'm audible, visible. जल्दी से बता दीजिए. Hi everyone, am I visible, audible, clearly? क्या मैं live आ चुकी हूँ? Am I live today? Yes or no? Yes. A very good evening to all of you. I hope all of you are एकदम बढ़िया, एकदम मस्त और एकदम ढिंचाक. A very good evening, Aditya, Arush, all A, right? Good evening, everyone. And today we are going to start a new chapter that is chemical bonding in our B2A series, Basics to Advanced series for NSEJS 2025 aspirants, right? So, guys, chemical bonding is one such chapter which is important for NSEJS. I won't say you have to spend a lot of time in doing chemical bonding because it is inorganic chemistry chapter, very much lengthy, so much of information and facts. But what I'm going to cover here in this series is specific to NSEJS. That much you are supposed to do if you want to clear NSEJS or any stage of junior science Olympiad, right? So let's be very specific in this chapter because otherwise it is a very huge, big chapter to do, right? Hi everyone. Okay, great. So today we are going to introduce chemical bond. We are going to do Lewis octet rule, right? Are you all ready to learn chemical bonding? Yes, guys. Are you all ready to learn chemical bonding? Yo. And also, on Saturday, on 21st of June, we had fantabulous celebration where all students, teachers, and the parents, they all came together to celebrate the success and hard work of students. I hope you are checking the community post of this channel. I am feeding the community post of this channel with the pictures, lot of pictures, right? From that event, from that well celebration, Vedantu Achievers League celebration 2025. I hope you all also are seeing all those pictures, the videos that we are going to post, of course, right? And you should feel motivated and inspired that you should also be coming next year after cracking NSEJS. Right, guys? Yes. Hi, Keshav Soni. You can study Keshav, but it has to be because they are more need oriented, and we should follow strategy to cover the maximum topics for NACGs, right? Because they are going to cover in 2 years of span that syllabus in NEET or JE channel, and that is as per JE or NEET demand, not NACG specific, right? Okay, guys, let's start today's session. So, guys, today we are going to do chemical bonding in this B2A series. So, what is a chemical bond? So, chemical bonding. So, most of the atoms, they just don't remain isolated. They tend to be with another atom, right? They have tendency to be with another atom. They don't just exist as a single atom. So, I'm sure you must have seen the atoms, right? You must have seen the atoms making bonds, making group with other atoms, right? So what is a chemical bond? Why most of the elements exist as a molecule cluster? They don't exist independent like noble gases. Yes. So what is a chemical bond? So basically, chemical bond is just a force of attraction, right? So what is a chemical bond? It is a force of attraction. The force of attraction which holds the constituent particles together, two atoms, two ions, two molecules, the force of attraction between them, which keeps them together, that is a chemical bond. So if anyone asks you what is a chemical bond, what you will say, guys? You will say it is a force of attraction, the pyar, the mohabbat between two particles, be it atom, be it ions, be it molecules, right? And why they make chemical bond, guys? Why atom cannot exist independently? Can any one of you tell me why atom has to make a bond? Why it just cannot be independent, isolated, all alone? क्या एटम भी एक सोशल एनिमल है जस्ट लाइक ह्यूमन इज एटम आल्सो अ सोशल एनिमल राइट सो गाइस बेसिकली this entire chemical bond formation reaction or whatever an atom or element is doing, that is just to attain the stability. That is the whole sole purpose. By making chemical bonds, atom is becoming more stable. So I usually ask this question while teaching chemical bond: why you are studying, guys? Why you are studying? Why you are putting a lot of effort preparing for NSEJS, such prestigious exam? At such young age, you are studying a lot of extra stuff than your school curriculum. Why you are studying a lot? Why you are getting exposed to various exams or various fields? Whatever you are doing, be it sport, be it study, whatever you are doing with your full effort, full energy, why you are doing so? Yes, just to become more stable. If I study this, if I crack this exam, if I excel in this field, I'll get a better opportunities to earn better, to have a good life, stable life, to get more stability in life. So whatever you are doing, the ultimate purpose is to become more stable, right? Yes, what all your actions are, karmas are, that is basically to become more stable, right? Yes, whatever you are doing is to become more stable. Same is the case with atoms, my dear students. They want to become more stable. So whatever they are doing, they are making the bonds, the force of attraction, that is to become more stable, right? Yes. So the only purpose for an atom to make a bond is to become more stable. Now you will ask me, ma'am, how they will become stable by making a bond? So there are two reasons behind it, guys. First is energy, right? Energy. So if you are attending my classes regularly, you must know energy is inversely proportional to the stability, right? If any species has more energy, it will be less stable, just like your younger brother or sister. They're more energetic. A toddler, an infant, they're more energetic. So they're less stable. They're unstable. They keep on falling. They keep on, breaking the stuff. If you have more energy all the time, you are unstable. You cannot sit in one place. There are many students in your class, I'm sure. Those who are very, unstable. They keep on hoping here and there, this seat, that seat, here and there. So more is the energy, lesser is the stability. And whenever there is attraction means love. Of course, attraction leads to more stability. If there is attraction, love, right, in the country, among the people, it will be more peaceful, more stable. Do you agree? More love, more attraction, more stability, right? So when an atom is making a bond, that means it is attracting the other atom. There is attraction. And if there is the attraction, there is a more stability, ma'am. If there is more stability, there will be decrease in energy, ma'am. That means if an atom is forming a bond, its energy is decreasing, it is becoming more stable, ma'am. Right? Yes. So that is why atom makes a bond to become more stable by releasing energy, by giving out energy, by making its energy decrease. Right? So this is the first how it is attaining stability, by releasing energy. So always remember, guys, whenever two atoms are making a bond, when there is a bond formation, there is a release of energy. Whenever there is a bond which is being formed, there is a release of energy. So bond formation means energy goes out, right? So you can see this table. This is a very famous potential energy curve. In chemistry, potential energy is not mgh, guys, because in chemistry we deal with microscopic particle, right? We don't talk about gravity. Not our atoms are falling down because of gravity, right? If gravity works at microscopic world, so all the atoms, all the molecule, all the oxygen, CO2 that you are living in, they should be at the ground only, right? So in chemistry, ma'am, what is potential energy then? Any one of you who's watching the lecture live, what is potential energy? What do you mean by potential energy in chemistry? It is not mgh, no gravity thing in chemistry. Gravity is a concept of macroscopic world, your physics concept. So guys, potential energy is the energy of interaction, two atom, two molecule, two particles, because of their interaction. Because of interaction means attraction or repulsion. Because of their interaction, what all energy changes are happening? What is the effect on energy? That is potential energy. So basically, in chemistry, what is potential energy? If I say potential energy in chemistry, that is the energy due to interaction between the particles, whether they are attracting each other, whether they are repelling each other, or they are not affecting each other, right? That is potential energy, guys. Got it? So two hydrogen atoms, they're very very far apart, not affecting each other, neither attracting nor repelling. So this is the potential energy. So when they come close at an optimum distance, they start attracting. More attraction means lesser energy. You can see there's a dip, there is a minima. At this minima, there is a bond formation, maximum attraction. Two atoms at an optimum distance, they are making a bond. Most stable, lowest energy. This dip, this minima shows that state of chemical bond formation. If they come more closer, what will happen? Ma'am, the electrons of this atom and the electron of this atom, because electrons are negatively charged, if they come more closer, of course, same charges repel each other. So there will be repulsion. And if there is a repulsion, energy will increase. So this is the world famous graph potential energy curve, the energy interaction curve. So two atoms very far apart, no attraction, no repulsion. They come close at an optimum distance. They will make a H2 molecule bond formation, and there is a dip, that minima is there. And if they come more closer, fight, repulsions, instability, more energy. Right, guys? Yo. So there is increase in energy. Done, 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 done. So I hope now you all get this graph. More attraction, less energy. More repulsion, more energy. Energy is inversely proportional to stability. Remember, right? So let's get back to our stability thing. So whenever there is a bond formation, there is a release of energy, and due to release of energy, your atoms become more stable. This is the first reason. How they attain stability? By making bond, by releasing energy. Got it, guys? Yups. Okay. Now the second thing. Second thing, please tell me. Yes, second thing. According to you, in the entire periodic table, all the elements, which elements are more stable? Quickly let me know. Which elements are more stable? Happy. They are stable. They don't need anyone to make them happy, to make them stable. So the most stable elements of the periodic table, of course, are noble gases, inert gases, group 18 elements. May I ask you why they are stable? Ma'am, because they have a stable configuration. They have a fully filled orbitals. That is why they are more stable. They don't want to lose electron or gain electron, ma'am. Very right, very right. So when other elements look at those noble gases, now they feel jealous. Every element want to be stable. So every other element feel, if I can acquire the configuration of a noble gas, I will also become stable. Right? Because the noble gases are stable due to their configuration. Right? So all the other elements think, if they will also acquire the noble gas configuration, they will have the electronic configuration just like a noble gas, they will also become stable. So another reason, another cause for chemical bond formation is to acquire, to attain the electronic configuration similar to that of noble gas. So What is the cause of chemical bonding? Stability. How they attain stability? By getting the noble gas configuration or by getting decrease in energy, by lowering the energy, right guys? Yes. So these are the reasons for bond formation, right? Now let us talk about what are the various types of bond, chemical bond. Interatomic bonds between the atoms, right? So we have a covalent bond. Interatomic means between the atoms. The force of attraction, the kind of bonds we should know while studying chemical bond. That is interatomic. One is covalent bond, another is ionic bond or electrovalent bond, and another is metallic bond. And there is a special type of covalent bond also known as dative bond or coordinate bond, right? A special type of covalent bond is a dative bond or coordinate bond, that also we should know. So these are the interatomic bond that you should know, you should study, right? We are going to cover the important parts of all these type of bonds in this chapter, right? And intermolecular is van der Waals forces and hydrogen bonding. I just told you chemical bond is a force of attraction, right? So the forces between the molecules, van der Waals forces and hydrogen bonding, right guys? So this is what we are supposed to cover in this chapter of chemical bonding, right? Now Lewis dot structure. What is a Lewis dot structure? So before that, Lewis, it is a very old theory, Lewis crystal theory. They try to explain the reason why the bond is being formed, right? By giving a rule known as octet rule. Octet means 8, right? So according to Lewis, every atom has a tendency to complete its octet to become stable, because noble gases other than helium, they have 8 valence electrons, right? Neon, argon, krypton, xenon, they all have 8 valence electron, 8 electrons in their outermost shell. So every atom, it has a tendency to have complete octet, means to have 8 valence electrons, right? So they are making a bond just to complete their octet. And if it is hydrogen, why hydrogen? Because hydrogen just has first shell, and first shell can maximum accommodate 2 electrons. That means your first shell will complete its, like your hydrogen will have a complete duplet. Duplet means 2 electrons. So Lewis, according to Lewis, right? Every atom has a tendency to get octet complete. That is why they are making a bond. They want to become stable by losing, by gaining, by sharing. They just want to have 8 electrons in their valence shell to become more stable, to become like a noble gas, right? So every atom has this tendency to have a complete octet, either by gaining electron or by losing electron or by sharing electron. All the effort they are doing just to become more stable, just to have their complete octet, right guys? Yes. So for example, let me take an example guys. For example, CH4, methane molecule. So you know carbon, how many valence electron carbon has? 1s2, 2s2, 2p2. Carbon has 4 electron in the valence shell, that is the second shell. So Lewis structure is putting that many dots around the symbol, that is equal to the number of valence electrons. So carbon has 4 valence electrons. So I will put 4 dots. These dots represent the valence electrons, the outermost shell electrons, right? So this carbon. Now CH4, carbon is making bond with hydrogen. Now hydrogens have 1 electron. Each hydrogen has 1 electron, and hydrogen wants to complete its duplet. So what they will do? Hydrogen and carbon will make a bond. One bond means 2 electrons. So they will share 1 electron of hydrogen, 1 will carbon, they share. Now after making this bond, how many electrons does this carbon has in the valence shell? 4 its own and 4 it is shared by hydrogen. So total 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons your carbon will have after making bond with hydrogen. That means the octet of CH4 is complete. It becomes stable after making the bonds with hydrogen. And also for hydrogen, earlier it was having 1 electron. After getting 1 electron from carbon, its duplet is complete, just like helium. Right? So that is why, according to Lewis, see, this molecule is stable because carbon has its complete octet. Right? For example, we have CO2. So what will happen? Carbon has 4 valence electron. How many valence electron oxygen has? 6. 1, 2, 3, 4, 5, 6. Let me put 6 dots around oxygen. Now, carbon needs 4 more electrons to complete the octet. And oxygen needs 2 electrons to complete the octet because already oxygen has 6 valence electrons and our carbon has 4 valence electrons. So what it will do? How CO2 is formed? So these bonds between carbon and oxygen. Now, one oxygen forms 2 bonds with the carbon. That means total it has 8 electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So complete octet for this oxygen. Same with this oxygen also has complete octet. Now carbon. 1, 2, 3, 4, 5, 6, 7, 8. So carbon also has a complete octet here. Right? So according to octet rule, why it is being formed? Just to complete the octet, to have 8 valence electron, they become stable, right? Let me take you the case of nitrogen molecule N2. Quickly tell me how many valence electron nitrogen has. So ma'am, nitrogen has 5 valence electron. Another nitrogen also have 5 valence electron, ma'am. Perfect. So each of them will need 3 more electron to complete their octet. Octet means to have 8 valence electron. 5 they already have. Now what they will do, ma'am? They will make a bond with each other. How many bonds they will make? 1, 2, 3. Now how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Now this nitrogen also has 8 electrons after making bond. This also has 8 electrons. So both of them has complete octet. That is why this N2 molecule exists. Right? Yes. Let me take the example of water. Jal hi jeevan hai, H2O. Now your oxygen we just saw 6 valence electron oxygen has. 1, 2, 3, 4, 5, 6. And hydrogen just has 1 electron. So hydrogen wants to complete its duplet, oxygen wants to complete its octet. So a hydrogen will make 1 bond with oxygen and oxygen will make 2 bond, 1 with each hydrogen. Now oxygen has complete octet here and your hydrogen will have complete duplet here, right guys? So this is what Lewis said about the chemical bond, that it was a primitive theory, very old theory, which explained, Lewis tried to explain why there is a bond formation. So according to Lewis, he gave a rule which is known as octet rule, that every atom has a tendency to attain 8 electron, right? By losing, by gaining, by sharing electron. So just to have those 8 electrons in their valence shell, they make bond, right? Got it, guys? I hope it is all clear. Yes. So I've just told you the case of H2O, 8 electrons acquired by oxygen and hydrogen, right? Cl2, you can see the case, one chlorine has 7 valence electron, another chlorine also have 7 valence electron. So by making a bond with each other, right? So these are the 7 electrons, 1 chlorine, 7 electrons, 1 chlorine. Now they will form a bond with each other. Now that means 7 and 1, right? So this 1 bond means 2 electrons. So now each chlorine has 8 valence electron. Each chlorine has complete octet. That is why the Cl2 molecule is there, right? Yes, duplet is also stability for hydrogen. Helium, because helium is a noble gas, and helium and hydrogen, they both have first shell is the valence shell, Aditya. So of course they can maximum have 2 electrons, na? They cannot have 4, right? So just like CH4, CCl4 also another example where after making bonds with each chlorine, carbon completes its octet, right? Ammonia. Another example is ammonia. As I just told you, nitrogen has 5 valence electrons. Let me draw 5 dots around nitrogen. Lewis symbol. Right? Now nitrogen has 5 valence electrons and it needs 3 more electrons to complete its octet. Now what it will do? It will make bonds with hydrogen. Each hydrogen will form one bond. It can form one bond. These are 3 hydrogen, which single electron, because hydrogen just has 1 electron. Now this nitrogen, hydrogen will share their electrons. Now after making this bond, how many electrons your nitrogen has? 1, 2, 3, 4, 5, its own, and 3 shared by hydrogen. So total 8 electrons. Right, guys? Yep. So that is the octet rule. Octet rule means to have 8 valence electrons. Got it? Yep. Let's move ahead, guys. Right? So when you got the 8th valence electron, it will become more stable, right? So many memes these days. I hope it is clear, guys. Yes. So what I told you, whenever you are writing the Lewis symbol, the dots around the symbol represents the valence electron, right? So you should also know how to write the Lewis dot structure, right? You should know how to write the Lewis dot structure. You are supposed to put that many dots around the symbol that is equal to the number of valence electrons. Yes. Got it, guys? So you can see hydrogen, there can be single bond. One hydrogen is being shared. One hydrogen, one electron, they share these 2 electrons and they become stable. Oxygen, double bond. One bond means 2 electrons. So if there is a double bond, that means 4 electrons are shared between 2 atoms. Here, one single bond, that means there is a 2 electron shared between 2 atoms. Nitrogen, triple bond, that means one bond means 2 electrons. That means 6 electrons are involved in bonding, right? 3 bond means 6 electrons. So one bond means 2 electrons are involved here, right? Got it, guys? So it can be a single bond, it can be a double bond, it can be a triple bond. So you can see the structure of ethane also, C2H6. How many valence electrons are there? Let me draw. Ethane, C2H6, we have 1, 2, right? This 4 electrons shared by each hydrogen 1, another hydrogen 2, another hydrogen 3. Here also hydrogen. So total 8 electrons on each carbon, right? You can see. Both the carbon has their complete octet and hydrogen has complete duplet. Right, guys? So Lewis Fossil says every atom has a tendency to complete its octet. That is why they're making chemical bonds. Yups, guys. We'll do that, Aditya, later on. Hybridization we'll do in chemical bonding and bit of it in organic chemistry. Right, guys? Now, tell me, does this molecule exist? Whatever molecule I am writing, do they exist? Do these molecules exist? Have you heard about these molecules? Are they existing? BeCl2, FbF3, PCl5, do they exist? Are they existing molecules? Yes. Quick, quick, quick. Do these molecules exist? Yes, they exist. They are stable. That is why they exist. Now the next question, my dear students, let's check whether they are following octet rule or not. Beryllium. Beryllium has 2 valence electron. Okay. Chlorine has 7 valence electron. So I am putting that many dots around chlorine, right? Now chlorine is making bond with beryllium. So by making a bond with beryllium, chlorine now has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So chlorine has complete octet. But what about beryllium, guys? What about beryllium? Beryllium, even after making bond, it just has 1, 2, 3, 4, 4 electrons. Is it following the octet rule given by Lewis? No, ma'am, it is not following the octet rule. It is having lesser electron than 8. So such compounds which have lesser electron than 8, we call them electron deficient compound. Electron deficient they are. Kami electron ki or hypovalent. Lesser electron than 8. Right? But it exists and it is stable also. Let us check about BF3. BF3, ma'am, boron has 3 valence electrons and it is making 1 bond with each. So fluorine now has complete octet, but not boron. So boron after making bond has 6 electrons. And it is not obeying the octet rule. Obeying octet rule means to have 8 valence electrons. Again, boron is having 6 electrons even after making bond, but still this molecule is stable and exists. Again, this is electron deficient, right? Let's talk about PCl5. Phosphorus has 5 valence electron, okay? And it is making bond with each chlorine, 1 bond with each chlorine. So after making bond, after sharing electron with chlorine, how many total electron, valence electron your phosphorus has? So phosphorus is making 5 bonds. 5 bond means 10 electron. Ma'am, it is having 10 electrons. More than 8, ma'am. How it can have more than 8, ma'am? Yes. So still this molecule exists and it is a stable molecule. Again, it is not obeying the octet rule because it is not having 8 electrons. Rather, it is having more than 8, 10 electrons. So such compound we call them, they have superoctet, expanded octet or hypervalent. Superoctet, expanded octet and or we can call it hypervalent. So those which have more than 8 electrons, we call them they are hypervalent, they have superoctet, they have expanded octet, or all those molecules which are having less than 8 electrons, we call them electron deficient they are, or we can call them hypervalent. So all of them do exist and they are stable. So what does this indicates, guys? Oh, ma'am, this indicates failure of Lewis theory, limitation. According to Lewis, the atom makes bond by completing their octet. But we do have such molecules existing which are either having more than 8 electron or less than 8 electron and they're stable. So this is the limitation of octet rule. And in fact, let me tell you about those molecules which have odd electrons also. NO2. So NO2 is such a molecule which has a single electron. What is this arrow? I will tell you later on. So single electron, not in a pair, odd electron species we will call them. So existence of such molecule is the reason for failure of Lewis octet rule. There is more to it. Why chemical bond formation happens? There is a more to it. I just told you what did I tell you? that this is an old story. How did Lewis explain the bond formation? But the existence of molecules, hypervalent, hypovalent, it is proved that there are, more to this story. So these are all Lewis structure, guys. You should know how to draw the Lewis structures, how the electrons are being shared. So this is all the snips taken from NCERT. So O2, H2, O3, NF3, you should know how the electrons are being here, right? So you should know how to draw the Lewis structure, how to show the bond formation. So limitations of octet rule, the existence of those molecules which have incomplete octet, you can say electron deficient molecules, BF3, LCl3, BCl3, they all are electron deficient molecules, right? Existence of those molecules like PCl5, SF6, IF7, right? Which have more than 8 electrons. Now you will ask me, ma'am, how they can accommodate more than 8 electrons? Because phosphorus, sulfur, iodine, they have d subshells also. Their valence shell has empty d subshell. You know, in third shell we have 3s, 3p, 3d is also there. So that extra electron is being accommodated. More than 8 electrons they can accommodate in their vacant d orbitals, right? Your phosphorus has 3s2, 3p, 3 configuration. 3d is empty, vacant. So it can have more than 8 electrons because d orbitals are also there. So those atoms or elements which have d subshells in the valence shell, which has d orbitals, they can expand their octet. But the elements which are just having the second shell as the valence shell, second period elements, because second shell has 2s and 2p. Second shell can maximum accommodate 8 electrons. So the elements belonging to second period of the periodic table, which has second shell as their valence shell, they cannot expand their octet. They cannot have more than 8 electrons in any of their compounds. So remember, these questions are being asked. If you see any second period molecule, beryllium, boron, right, nitrogen, oxygen, fluorine, having more than 8 electrons in a molecule, that is a wrong, that is invalid, that is not correct molecule, that doesn't exist, right? Yes. So many times questions are being asked, which of the following molecule exists or not? So just look for if any second period element, the element which has second shell is the valence shell, it is having more than 8 electrons in a molecule after making bond, that molecule cannot exist, guys. Remember this, only those atoms which has vacant d orbitals can expand their octet. That means only they can have more than 8 valence electrons, right, guys? So these are the limitations of octet rule. So odd electron species also exist. Hi Divyanshu. The electrons having more than 8 electrons also exist. The electrons having less than 8 electrons also exist. So all these are the exceptions, or you can say the limitations of octet rule, right? So that shows there is some better, more correct theory which explains the chemical bond formation. And noble gases, guys, noble gases, they have complete octet. Xenon has complete octet, krypton has complete octet, but still they form compounds. So why they form compound if they are stable, right? Yes, so let's solve questions now. Which is not an exception to octet rule, means which is following the octet rule, which has 8 valence electron. BF3, SiCl4, BeCl2, ClO2, which is following the octet rule, basically they're asking. Yes, of course, organic, inorganic is already always there in all the stages. BF3, SiCl4, BeCl2, ClO2. Answer please. Which is following octet rule, which has 8 valence electron, guys? This is what they're asking. BF3, I just told you exception, limitation, 6 electrons. SiCl4. Silicon has 4 valence electron and it is forming 4 bonds. That means total 8 electrons silicon is having. That means it is following octet rule. It is not an exception. BeCl2 is an exception. ClO2 is an odd electron species. So all of them, A, C and D, they are not obeying the octet rule. Only B is obeying the octet rule, guys. Now the next. Which among the following chemical bonds were described by Cossel and Lewis? So Cossel and Lewis gave octet rule, right? Octet rule. Yes, definitely, Divyanshu will do that. Octet rule. Cossel and Lewis. Can you please tell me which bond they talk about in this theory? Ionic bond is formed by the losing and gaining of electron. Covalent bond, sharing of electrons. So they talk about D, both kind of bonds, either by gaining or losing or by sharing. The electron atom has tendency to acquire noble gas configuration. Now the next is your homework question. The octet rule is not obeyed by CO2, BCl3, H2 or SiF4. This is the homework question. Please do not forget to write your answer in the comment section, guys. Right? Though it is pretty easy, but just make sure that you write your answer in the comment section of the video, and do check the community post of the channel because I am posting a lot of pictures there from the valedictory function, VAL function, right? Vedantu Achievers League 2025. So get inspired by those students, and I really wish to meet you all next year by cracking NSEJS 2025. Right, guys? Yes. So we have a car batch running for NSEJS aspirant, J or NEET Foundation daily session. This is the schedule, and we have your B2A series in English for NSEJS aspirant. And there is a change, guys. There is a change in the schedule. Please note who are those who are following the B2A series. Now, this week onwards, physics session is on Monday. Every Monday, 7 to 8, you will have physics session instead of Wednesday. So, Monday for physics, Tuesday for chemistry, and Thursday for biology B2A series, basics to advanced series for NSEJS aspirant. So, if you follow this channel, guys, dedicatedly, without any other thing, if you solve the assignments that we are providing in our car batch, if you are regularly attending the sessions here, if you are a subscriber here, you are following all the content we are providing here, we are very sure that you will crack your NSEJS exam, right? Got it, guys? So just to make sure that you are, if you want to do good in science, if science is your career, right? If you're thinking to take up as a career, be it IIT, be it AIMS, be it research, foreign universities, if you are interested to have a career in science, this is the one channel that will give you all the content, and you know it, right? So I have been delivering this junior science specific content since 2020, regularly, consistently on this channel, right? The consistency, I always say, is the key to success. मैं तुम्हें भी बोलती हूँ, be consistent in your studies, right? This is what I always tell my students. If you are consistent in your preparation, in your efforts, you will crack the exam. So the same I follow. I have been consistent in providing you the content related to Junior Science Olympiad, science specific, the foundation for JEE NEET. This is one channel that you should definitely follow for all junior science, Olympiad content. Or if you want to have a strong foundation for your JEE or NEET future exam. I'm not mincing words. I'm not misleading you. Trust me, guys. We are providing the best content on this channel required for Science Olympiads, right? Yes. So make sure that you are a subscriber of this channel and press the bell icon so that any content, any video we are putting up, you are following that. You will get the notification. Right, guys? Very good. Okay. So, NSEJS aspirants, this is the one book that you should all have. It is available on Flipkart, Amazon, and Vedantu eStore. Practice book contain all the three physics, chemistry, biology subjects required for your practice, previous year questions, basic objective. No book in the market which gives you the practice specific to NSEJS. So go and buy this book, guys. Right? And please hit the like button. Science ka content, science lover ho, so do not forget to like every video on the channel, right? Because we are putting a lot of effort to provide you the best content that can really help you to crack these prestigious exams, right? So, bye. Thank you, Divyanshu. Take care. God bless you all. Keep learning, keep growing. Let's bring goal for India, guys.